All right, everybody. Today's section is our first section on using square roots. And if you look at your note packet, they start you out with just talking about a little example of what if you had a square. All right, and I'll do my best drawing of a square right now. Now, what we know about a square is that all the sides are the same. So usually in math, we put little hash marks on the sides of figures, and that means all of those are the same. And I believe they start out by saying, what if your sides were all 4 centimeters? And no, I'm sorry, they say the area is equal to 4 centimeters squared. Okay, and so I'm going to take that 4 right off of here down here. And they say, well, what would be the length of each one of the sides of this square? So we know that the area of a square follows that formula right there, where A is the area and S is the length of each side. So if I just simply plug this in, if I plug this in right here, I have 4 equals S squared. And just thinking about, well, what number would I put in to S in order to make that true? Well, 2 squared would be equal to 4. Okay, because, right, and it's important to know why, because 2 times 2 equals 4. All right, so the idea of squaring a number we've done before. You take the number by itself. But the idea of a square root, that's something a little new to us. All right, if we take the square root, I want to think of that as undoing squaring. All right, and I know that's not the best terminology to maybe use for that, but it really is what it's doing. You're undoing squaring. So we have to introduce another symbol here. This is the radical symbol. If I take the square root of 4, I get 2. Now, one thing I got to notice, or one thing I got to point out before we go too far, is notice I took the square root, and that means the radical symbol. I'm going to label that. This is the radical symbol, okay, or the square root symbol. When I take the square root and I actually square root something, that radical symbol, it went away because you actually did it. All right, it's like when you take 6 and divide by 3. Well, your answer, if you're going to put your answer over here, it would just be 2. It wouldn't be 2 with the division symbol around it, right? Because you did the division. All right, so when you take the square root, that radical symbol then goes away. All right, so let's try to look at the next piece of information here. Oh, and what I didn't mention is this radical 4. That's considered a perfect square because it came out to a nice whole number. They say that on the packet. All right, so let's list. These are really good numbers to know, and the more you work with them, the more you'll know them. All right, let's list. Whoops, I got to switch over here. Let's list the perfect squares. All right, up through 12. All right, and these, like I said, are really handy to know by heart because they're just nice. You don't have to go to your calculator. You don't have to. It should be just like automatic. All right. So, what's the square root of 1? Well, the square root of 1 is 1. All right. And why is that? Because 1 times 1 equals 1. All right. What's the square root of 4? Well, that's the one we did. That would be 2 because 2 times 2 equals 4. So again, I'm undoing squaring. All right, the square root of 9 would be 3. Again, because 3 times 3 equals 9. Alrighty. And if I want to finish up these perfect squares here, square root of 16 would be 4. Again, because 4 times 4 equals 16. Square root of 25 is 5. Square root of 36 is 6. And these are all go back to your multiplication tables, right? These are your multiplication tables from elementary school, really. Square root of 49 would be 7. Square root of 64 would be 8. Square root of 81 would be 9. And I'm using the same reasoning in all of these. This would be 10. Square root of 121 is 11. And square root of 144, that's going to be 12. All right, so all of these are really good to know by heart. All right, it just makes things a lot easier, and you might not know them now, but as we work more with square roots, they're going to sink in. All right, and again, these are called perfect squares. All right, they're called perfect squares because when you take the square root, they turn out to be a whole number. Okay, now part of what we want to be able to do is we want to try to envision where are these falling on the number line. All right, well these are pretty easy. All right, this would be square root of 1. Okay, would be right there. The square root of 4, okay, is going to fall right there. All right, square root of 9 is going to fall right there. All right, and this gets kind of messy a little bit if you don't keep them sectioned out here. How about the square root of 16? That's going to be 4 right there, right? And the square root of 25. Okay, and that one's going to go right there. All right, you can see they're just going along. These just count up by ones. All right, so I'm going to put some of them down here. Square root of 36 is going to go right on the 6. Square root of 49, right, is going to go there. Square root of, what's the next one, 64, all right, is going to be right at the 8. And let's see, we'll go on top for these other ones. Square root of 81, it's going to be right there. Square root of 100, right there. Square root of 11, no, sorry, 121. It's going to be right on the 11. Okay, and the square root of 144 is going to be right on 12. Okay, so you can see all of these fall on nice whole numbers. That's why they're called perfect squares, once again. Now, some square roots, many square roots obviously, do not fall on whole numbers. All right, so let's turn these off and let's put in these. Now, where would these fall on the number line? Okay, and what I'm going to do is I'm going to look at these perfect squares and I'm going to try to figure out, well, where would they fall? Well, the square root of 3, right? Square root of 3, and I don't know why. Oh, wait a minute. Yes, I do. Square root of 3, there, I could put a circle around that, would be in between the square root of 1 and the square root of 4, right? Because the square root of 1 is 1. The square root of 4 is 2. So that means the square root of 3 would be in between 1 and 2. All right? So I'm not going to be exact in this. I'm going to just draw a line and say it's going to be somewhere in between 1 and 2. All right? See how I did that? Okay, how about the square root of 2? Okay, square root of 2. Again, that's going to be in between square root of 1 and the square root of 3. All right, square root of 1 is 1. Square root of 3, well, I don't know that one for sure, but I know approximately where it is. So the square root of 2 is going to be in between those two. It's going to be in there somewhere. All right? So I wanted you guys to see like where these fall on the number line. Let me switch a different color here. Let's do the square root of radical 6. Well, what are those going to be in between? Well, it's going to be and let's just take some perfect squares. Let's make it a little easier. Let's take the perfect squares, and what number would those be in between? Well, the smallest perfect square below 6 would be the square root of 4. All right? The next highest is the square root of 9. Well, the square root of 4 is 2. Square root of 9 is 3. So that tells me that the square root of 6 is in between 2 and 3. Okay? So I can go down here and put square root of 6. That's going to be somewhere in there, right? In between 2 and 3. How about 10? We'll do another color for 10 here. Square root of 10, again, let's take the perfect squares. Well, square root of 9 would be the next lowest number that's a perfect square. And the next higher number, if I just go down here to my number line, the next higher number is going to be the square root of 16. So that's 3. That's 4. So that means the square root of 10 is in between 3 and 4. Okay, so square root of 10 is going to be somewhere in here. I don't know if it's going to be directly in between. It's probably not, but I know it's somewhere in between 3 and 4. And in the future, we'll get out calculators and we'll get a little more precise, all right? So how about these other two here? Square root of 23. Now, where is that going to fall? Well, where is the perfect squares where this would fall in between? There would be right here. 16 and 25, all right? Square root of 16 would be 4. Square root of 25, well, that's 5. So I know the square root of 23 is somewhere in between 4 and 5. So again, I'm going to put a little arrow here, and it's getting messy. All right, that's going to be 23, square root of 23. Okay, and one more. How about the square root of 94? All right, square root of 94. I've got another color here. We can go, let's see, look at these numbers. 81 and 100. 94 would be in between 84 and 100, right? So square root of 81 would be 9, and the square root of 100 would be 10. So I know the square root of 94 is in between 9 and 10. So right in here somewhere, again, I don't know exactly where, not worried about that right now, the square root of 94 is going to be in between those two. All right? So that's really what I wanted to look at today is what is a square root, okay? What is a perfect square? And then where do they fall? Approximately where do they fall on that number line? All right, so hopefully that was okay. You followed along. If you have to rewatch it, that's fine. It's not too long of a video. And take care. We'll see you tomorrow. Thanks for watching.